Good morning and welcome to Conceptual Math. So, uh, as you may or may not have realized, conceptual math is essentially for those of you who are heading into the School of Liberal Arts. And many of you will be taking courses that rely on a little bit of research. This includes social work majors and sociology majors, and a variety of other folks. So, it's important that everyone, no matter what your major is going to be, even an English major, should have at least a basic understanding of statistics. And so that's really the reason why Yasmin and Cinda and all of the folks who have uh, put me up to this have asked me to teach you guys at least a little bit of statistics. Now, before you get any concerns at all, I do want you to be aware that this is not truly a math course. All right. I want you to have and develop a basic understanding of statistics and how statistics are used in everyday life. All right. Anytime that you read an article or a newspaper or a journal article in your major field, whatever that happens to be, there's probably going to be at least some statistical analysis associated with this. And so it's important that you're able to read this and comprehend what the statistical analysis is actually talking about. This becomes even more important when you are a researcher, all right? And whether that's research in social work or research in biology or research in any major field, you should have at least a basic understanding of how statistics work and how to actually calculate these statistics. So, all in all, the goals of this very first chapter and today's mission is are listed here on this slide. All right, why do researchers learn statistics? Why is it important to learn statistics? What is the general purpose of statistical procedures? What does it prove? What does it show? Why do we do statistics and why are they important? And finally, the basic math that's needed. Now, before you get worried about that, we're just going to be dealing with addition, subtraction, multiplication, and division. All right, this is stuff that you've been doing since grammar school. All right. Occasionally, I may ask you to square a number or even take a square root, but you do have a magic number box available for you that will do most of the arithmetic that you need for this course all by yourself. So don't fret about it. Don't worry about it. We should be okay. Now, students ask all the time, why do I need to learn statistics? What's the point of me doing this? What is a statistic? Why do I have to learn it? Why is it important? What do researchers do with statistics? What's the point of all of this? And so in this first chapter, this introductory chapter, I want to spend a little time at least for the first half of this, going through these commonly asked questions about statistics, and hopefully easing your mind a little bit about what it is we're going to do this summer. All right, and hopefully, if you do take a statistics course in the fall or sometime over the course of the next 4 years. This will put your mind at ease and you'll understand why exactly it is that you're doing the things that you do. So right off the bat, let's start with the first question, the most important question. All right, what are statistics? Okay, well, statistics refer to statistical procedures and the answers that we obtain from those procedures. Now, that may sound like a lot of gobbledygook, and one of the first things they tell you is you can't use a word to define itself. But all in all, I want to illustrate this. All right, first, it is very infrequent that you are able to make a measurement on every possible or available person. So think about this. If I asked you to measure or calculate the average height of human beings, well, in order to do that, you would have to measure the height of 7.5 billion people. You think that's possible? I don't. All right, that would take more than a lifetime. And by the time you got through with it, there'd be more people being born and people have died and everything else. And so rather than do that, what we do is we take a sample of human beings, all right? 100 people, 1,000 people, maybe even 1,000,000, all right? Although that's probably pushing it. And a statistic is used to calculate the average height of a human being, not using the entire sample size, but just a portion of that sample size. All right. So statistics refer to statistical procedures and the answers obtained from those procedures. And if we do them correctly, we can have a fairly good estimate, a very strong estimate of whatever it is we're measuring, the height of human beings. All right, if we measure 1,000 people, and the average height of that 1,000 people is probably pretty close to the average height of people on Earth. So, again, what are statistics? Well, behavioral sciences are based on empirical research. Now, the word empirical just means knowledge obtained through the observation of events, all right? You watch something, or you measure something, or you examine something in some detail. And so, if you're watching, a population of frogs in a pond, or goldfish in a lake, or people in a dorm, for example, then what you have to do is you have to make specific measurements, all right? And those measurements are translated into what we call scores, and the scores are then referred to as data. The collection of scores that you obtain by making all of these measurements are referred to as data. Now, data is a plural word, all right? A single data point is called a datum, all right? It's from the Latin. So any of you who went to Catholic school and studied Latin, you might be aware of that, all right? So in order to know what we're doing in terms of statistics, we need to know that we're making measurements, that each measurement becomes a data point, and then we use that data in a statistical calculation to demonstrate whether or not two groups, for example, are different. All right. For example, let's say we wanted to compare the height of females to the height of males. All right. If that's the case, then we put the males in one group, the females in the other, and we compare them. All right. So these statistical procedures are used to organize the data, to summarize the data, and then to communicate the data. Okay? And then finally, they're used to conclude what exactly the data indicate. Now, what does that mean? Well, again, let's say we're comparing the average height of males to the average height of females. Okay, so I'm going to take my group of, let's say, 100 people. Okay, and I might have 50 males and 50 females, but I might have 45 males and 55 females. It doesn't really matter, because statistics don't need to be calculated on equal sized groups. They should be as equal as possible, but it's not always possible to get evenly grouped numbers. And so what we do in this case is to separate our two groups, right? Let's say we have 45 females and 55 males. We measure every single person, and we take a data point. We have a data point for each of the females and each of the males. We then calculate perhaps an average height for the males and the females, and that is the summary. All right, and probably we would find that the females are on average shorter than the males. Now, that doesn't mean that every female is shorter than every male. It just means that on average they are. It's a summary, and that's really what an average calculation is. However, The important aspect of this is to compare the two groups. And even though the females on average are shorter than the males, are the two groups really different? And that is the conclusion that statistics will allow you to calculate. All right. We'll get into some examples of all of this as the course goes on. So, how do I learn statistics? All right. More than anything else, you need to learn when to use each statistical procedure, why to use each statistical procedure, and how to interpret each statistical procedure. Now, in our case, this summer, I'm going to ask you to do two major things each day, each Tuesday and each Thursday. The first thing I want you to do is watch this video, all right, and the series of videos that I'm going to post on Canvas for you. But the second major thing, and this is exceptionally important, is I want you to get out your textbook every day and read it, okay? As a matter of fact, my advice to you is read the chapter before you watch the video, and then read the chapter again after you've watched the video. All right, because that is one of the best ways to actually learn material in college. And this is true not just for this course, but for any course. Okay, read, listen, read again. Okay, and if you do that for all of your college courses for the next 4 years, you're going to do very, very well, because you're getting multiple perspectives here. You're getting the author's perspective, then you're getting my perspective, and then you're getting the author's perspective again. It will help you to tie all of this together. All right. But in terms of learning statistical analyses, and again, this is not going to take place for a few more weeks, but you need to the three questions you need to ask are when, why, and how. Okay, when, why, and how. Okay. Now, I told you right off the bat that this is not really truly a math course, although we do call the course conceptual math. But we are going to have to do a little bit of arithmetic, all right? I won't ask you to do too much algebra, maybe just a little bit, and certainly no pre-calc or calculus or anything beyond that, all right? But you're going to have to be able to identify a formula, identify the variables within that formula, and then perform the order of operations for that formula correctly so that you can come up with the correct answer to a particular question. So make sure that you are ready, able, and willing to do a little bit of calculation. And again, use your magic number box, okay? It's right here in front of you. Don't forget to have a look at it. Now, one of the other big issues that students studying statistics have is they get very freaked out by the notation of statistics. All right, you look at formulas and symbols and that sort of thing, and people get really, really nervous about it. It looks like a foreign language. It looks like it's written in Greek or hieroglyphics or something. All right, don't panic. Okay, we just remember that each term in a word or a formula or anything else means a very specific thing. And if you can follow what the meanings are, you should be able to follow the notation quite easily. All right. The notation itself is designed to make it easier for you to interpret the results and interpret what exactly you have to do, rather than writing it all out by hand, all right, and in words. So basic statistical notation, by definition, is the standardized code for symbolizing the mathematical operations performed in the formulas and for symbolizing the answers we obtain. So what does that mean? All right, it means that when we write 2 plus 2 is 4, we could write out the words 2 plus 2 equals 4. Now, I'm assuming that you can all read, so you can read that. I know the handwriting's a little sloppy, but I'm trying to write here with a mouse. It's not so easy. But whoopsie daisy. But we could also say that 2 plus 2 equals 4. And so this is how to write this in symbolic notation. And so statistical notation is the standardized code for symbolizing the mathematical operations performed in the formulas and for symbolizing the answers we obtain. All right. I think the second line that I've written here is much easier to get through than the first line. All right, even though the first line is written in plain old English. Okay, so what are we going to do here with all of this? All right, well, in terms of our work, mathematical operations that you need to know about are as follows. All right, addition, subtraction, division, and multiplication. Easy peasy, right? So if X or Y stand for each individual score obtained in a study, okay? So X represents the person, Y represents the person's height. Seems easy enough, right? X represents the frog, and Y represents the number of offspring that the frog has. All right. X represents the tree, and Y represents the number of leaves on that tree. Okay. That's all that the variables X and Y really refer to. Now, addition is simply symbolized as X plus Y, right? That's addition, okay? Subtraction is given as X minus Y. Division is given as X divided by Y, or the quotient X over Y. And multiplication can be written as XY, or X in parentheses Y, or XY. Now, we try to get away from using the little X as a multiplication symbol because it gets confusing when we use an X. But you can do that. You can also use the symbolization of X dot Y. That means multiplication as well. And if you're going to use your computer to do this, or even some calculators, you might use the asterisk X times Y. All right. So how do we do this with an actual example here? Well, if the variable X equals 6 and the variable Y equals 2, then if we were to do an addition problem here and say that X plus, or to try to find X plus Y, then X plus Y equals 6 plus 2, right? Because X is equal to 6 and Y is equal to 2. Well, obviously 6 plus 2 equals 8. And so there is our answer here, right? The interpretation of X plus Y is 8. If we did X minus Y, then we would have, of course, 6 minus 2. And the interpretation of X minus Y in this case is 4, right? Because 6 minus 2 is 4. X divided by Y is 6 divided by 2. And so therefore, the interpretation of X divided by Y is 6 divided by 2, or 3. Okay, so X divided by Y is equal to 3. And finally, in this case, X times Y, represented in any of the 3 ways that's shown on the screen, or in the ways that I showed you in the previous slide, is simply 6 times 2. And of course, 6 times 2, X times Y, in this case, is interpreted as 12. All right. So in any of these 4 basic mathematical operations, you simply take the 2 numbers and do what the operation tells you. And if you can do this, then you can do statistics. All right. It's not, it really is no different than the basic mathematical operations that you've probably been learning since you were in kindergarten. All right. Now, on a little bit more complex note, all right, let's start with, or let's talk about the idea of x squared and the square root of x. All right, this symbol that you see here, x with the exponent 2 represented here, means x squared. Okay, and what that literally means is x times x. All right, and so if we go back to our original definition of x and say that x is equal to 6, then x squared is equal to 6 squared, which is 6 times 6. And of course, the value 6 times 6, or if you had 6 sixes, you would have a grand total of 36 individuals, okay, or 36 data points if you want, okay, depending on what your operation is looking for, all right? But 6 squared is equal to 36. On the other hand, the square root of x is equal to or 2.45, all right? And the reason for that is because if you square 2.45, you get 6. Now, if you don't believe that, take out your magic number box and type in the square root of 6. Now, every kind of calculator actually does or has a different way of calculating square roots, so you have to know your own calculator. And I can help you with this via Zoom or email if you are having any troubles with it. But make sure that you know how to do the square root of x. And by the way, x squared, there's usually an x squared button on your calculators as well. Know how to use your calculators. Okay, so this is where I'm going to end our first video. This is going to be the first of 2 videos on chapter 1. So stay tuned for the second one. And I hope you learned something.